Ever found yourself just staring at a loading spinner, wondering what's the holdup? Well, a lot of the time, the real culprit is a slow database. So today, we're going to pull back the curtain and dive deep into the art and science of making your databases fly.
Here's the plan. First up, we're going to diagnose the problem. Why do our databases even get slow in the first place? Then, we'll get into the secret sauce, indexing. After that, we'll open up an expert's toolkit to see all the different types. Then learn how to write smarter queries to actually use them. And finally, we'll zoom out and see how this all fits into optimizing the entire system.
All right, let's just cut to the chase. In pretty much any app you build, database latency is the enemy. It's that invisible force that can grind an otherwise amazing user experience to a screeching halt.
You know, one of the most obvious signs of trouble is something called a DB read timeout. It's basically your app's patience meter. It asks the database for something, starts a timer, and if the database takes too long, the app just gives up. Our whole mission here is to make that database so ridiculously fast that the timer never, ever runs out.
So how do we make that happen? Well, the number one most powerful tool we have is database indexing. This isn't just a minor tweak. This is a fundamental technique that can totally transform your app's performance.
Okay, so what is an index really? The absolute best way to think about it is like the index in the back of a textbook, right? Instead of reading every single page to find what you're looking for, you just flip to the back, find the keyword, and it tells you the exact page to go to. A database index does precisely that for your data.
And this is where you really see the difference. I mean, it's night and day. Without an index, you get what's called a full table scan. The database literally has to read every single row. I mean, that's like trying to find one specific needle in a giant haystack by looking at every single piece of straw. It's crazy. But with an index, it does an index scan. It's like having a GPS that takes you right to the needle. The speed difference is just unbelievable, especially as your data starts to pile up. Let's make this super clear with an example. Imagine we have a huge table of users, and we slap an index on the age column. If we search for everyone who's 30, the database doesn't bother looking at anyone who's 25 or 40. The index acts like a guide, pointing the database straight to the records for 30-year-olds, completely skipping everything else. Think of all the work it just saved.
So what do you get out of all this? Well, for starters, your queries get lightning fast. You're reading way less from the disk, which is a huge bottleneck. Sorting data becomes a breeze. And this is the big one. Your performance stays consistent and snappy, even as your tables grow from 1,000 rows to 1 billion rows.
Okay, but it can't all be magic, right? There are a couple of trade-offs you gotta know about. First off, indexes themselves take up space on your disk. And second, and this is a big one for senior engineers to consider, they add a tiny bit of work every time you write data. When you do an insert, update, or delete, the database also has to update the index. That means you can't just index everything. You have to be smart about it.
All right, so we get why we need indexing. Now let's get into the fun part, the what. See, it's not just one thing called an index. It's more like a whole toolkit, and every tool is built for a very specific job. Let's open it up.
Okay, let's kick things off with the fundamentals, the ones you'll see all the time. Your primary index? The database usually handles that for you on the primary key. Now, a clustered index is kind of special. It physically resorts the data on the disk. That's why you can only have one. Most common are non-clustered indexes. They're separate lookup tables, and you can have a bunch of them. And behind the scenes, most of these use something called a B tree, which is just a super efficient way to organize the data for quick lookups. Okay, ready to level up? Let's look at some more specialized tools. A hash index is ridiculously fast if you're looking for an exact match, like searching by an email address. But, and here's the catch, it's no good for finding a range of things. And then you've got the bitmap index. This thing is genius for columns that have only a few possible values, like a status that can only be active or inactive. Super efficient for analytics.
All right, let's wrap up our tour of the toolkit with the real pro-level stuff. Got a query that often filters by two things at once, like last name and first name? That's what a composite index is for. A covering index is a total game changer for performance. It's an index that has all the data your query needs right inside it, so the database doesn't even need to touch the main table. And if you're doing text search, the magic behind that is an inverted index.
Okay, theory's great. The toolkit is cool, but what about when you're actually sitting there writing code? How does this all translate? Let's get practical and see how to use all this.
Here's a quick checklist for writing SQL that doesn't make your database cry. Rule number 1, if you're using a column in a where clause or a join, it better have an index on it, period. Second, only ask for the columns you actually need. And please, please, please stop using select star in your production code. Just don't. And a pro tip, always try to filter with where before you group data, instead of using having after. It just saves so much work.
Okay, I'm going to show you a classic trap that even experienced devs fall into. So, look at this query. Seems innocent enough, right? We just want all the orders from 2025. But that little year function right there, that completely kills our index. The database can't use it. So what does it do? It has to go through every single row in the table, run the function, and then check the result. It's incredibly slow.
Now watch this. Check out the optimized version.
See what we did? Instead of running a function on the column, we just gave it a simple date range. Now the database can use that super fast B-tree index on order date and jump directly to the right data. It's such a small change in the code, but the performance difference can be absolutely massive, like orders of magnitude faster.
Okay, so writing fast queries is a huge piece of the puzzle. But it's not the whole puzzle. To really get top-tier performance, we've got to zoom out and look at the whole system.
And the massive part of that bigger picture is something called connection pooling. You might not realize this, but opening a new connection to your database is actually really expensive. It takes time, it takes resources. Connection pooling is the clever trick to get around that by keeping a cache of connections ready to go.
And the way it works is actually pretty simple. When your app first boots up, it opens a bunch of connections and just keeps them on standby in a pool. Then, when a request comes in that needs the database, your app just grabs one from the pool. And here's the key. When it's done, it doesn't close the connection. It just puts it back in the pool, ready for the next request to use it instantly.
So if we put it all together, a really solid performance strategy comes down to 4 main things. First, you've got your efficient queries, which we now know are all about smart indexing. Second, smart database design, like breaking up huge tables. Third, making your application behave well with things like connection pooling. And fourth, you have to keep an eye on things. Continuously monitor for slow queries so you can fix them.
You know, when you boil it all down, it really comes back to one simple idea: providing efficient paths to get to your data. And that's why mastering this stuff, especially indexing, isn't just some nice little skill to have. For building high-performance, scalable apps, it's absolutely essential. So, I'll leave you with this one question to think about for your own work. Your database is great at generating data. We know that. But is it generating speed too? Thanks for joining me.